Hello students, welcome to Educate. We are going to continue with the numericals of chapter Oscillation. In previous lecture, we have studied till question number 12. Now, we are going to continue with question number 13. So, question number 13 says that there are two diagrams. One diagram is like in one diagram situation is like this. There is a spring with a spring constant K, and here there is mass M, and a force F is applied on it. And in second diagram there is a spring and two masses. This is also M and this is M, right? And force F is here and force F is here. We have to find out the maximum extension produced. So question number 13 we are talking about. So in both the cases you will observe that F equal to minus Kx will hold. Here also F equal to minus Kx. It means X will be in magnitude F upon K. X equal to F upon K. So this is first case. Now, second situation says if these masses are released, in that case, what will be the expression for time period, right? So in first case, expression for time period will be T equal to 2 pi root M upon K. But in second case, you have to be very careful. Here K will change. So it will become, say, K dash. K dash will be K plus K. Right? Now, the expression for time period will become 2 pi root of M upon 2K. Situation is obvious. This mass, this will vibrate like this will also vibrate. So double effect you have to consider. So because of that, expression for time period becomes T equal to 2 pi root M upon 2K. Now we are going to see next question. Next question says, the piston in the cylinder head of locomotive has a stroke twice the amplitude of 1 meter. If the piston moves with a simple harmonic motion with an angular frequency of 200 radian per minute, what is maximum speed? So here we have information. What it says, the piston in the cylinder head of locomotive has a stroke twice the amplitude. So we can find amplitude. So what is amplitude? Amplitude will be half of, this is 1 meter. So just write half meter, right? And then angular frequency is given. Angular frequency means omega. So omega is given as 200 radian per minute. So we can convert it into seconds. So we can write it 200 divided by 60 radian per second, right? We can simplify, this will be 10 by 3, right? And we have to find out what is maximum speed. If you remember the expression, if we start from x equal to a cos omega t and we differentiate it, we get dx upon dt, which is equal to a omega sine omega t with negative sign, right? And if we find its maximum value in magnitude, so V max will be equal to sine omega t will become 1. So it will be A omega. So all that we need is value of A and omega. Here in our question, A is half meter and omega is 10 by 3 radian per second. So we can say that V maximum is equal to 1 by 2 multiplied by 10 by 3. So 5 times. So this will become 5 by 3 meter per second. I think you have understood. Let's take next question. Now, next question says the acceleration due to gravity on the surface of moon is 1.7 meter per second square. So we can write it here. G moon is equal to 1.7 meter per second square. What is the time period of simple pendulum on the surface of moon? If time period on the surface of earth is given as T earth is 3.5 second, T moon is to be found, length of the pendulum will remain same, and value of G is given 9.8 meter per second square on the surface of earth. That you know very well. So here we have to write the formula, then we will compare it. So let's write the expression for time period. If you remember, time period for simple pendulum is given by T equal to 2 pi root of L upon G. So we can generalize it, T earth divided by T moon, right? So it will become 2 pi root L divided by G earth whole divided by 2 pi root L divided by G moon, right? Now what happens? 2 pi will cancel out, root L will cancel out, and this will get inverted. So we will get G moon divided by G earth, right? Now we have to find out T moon. So we can make cross multiplication. So T moon will be equal to T earth multiplied by root of G earth divided by G moon, right? Now, T earth is given in our question as 3.5 multiplied by square root of G earth is 9.8 divided by G moon is 1.7. So, what will it give? 3.5 multiplied by around 6 times, almost 6 times you can say. So root 6. Now we can evaluate the value of root 6. So what is root 6? Just take 6, put here 0, 0, 0, 0, just up to 2 places of decimal we are going to evaluate it. So 2, 2. So this will become 4, then 2, put here decimal, then 2 zeros, so this will become 4, and then 3 times, 4 times, if we take it 4 times, so it will become 176, and then we can proceed. So around 2.43 I think. So after putting that value, what do we get? So it will come out to be almost 8.4 second. I think you have understood. Now Let's proceed. So next question is, a simple pendulum of length L and having a bob of mass m is suspended in a car. The car is moving on a circular track of radius r with uniform speed v. If the pendulum makes small oscillations in a radial direction about its equilibrium position, what will be the time period? So here we have to consider two accelerations. As you know, this is question number 16. You know, t is given by 2 pi root of L upon g. Here, this value of g must be changed by combined effect of acceleration due to gravity and that of centripetal acceleration. So let's write it as g dash. So our sole concern is to find the value of g dash. So here there will be two accelerations. So g dash will be equal to acceleration due to gravity. Suppose this is like this, and then there will be another acceleration. So this will be v square divided by r, and this will be g, and both are at 90 degree. So we can write its value. So g dash will be square root of g square plus v square upon r whole square, or it will become g square plus v power 4 divided by r square. So we can put this value over here. So we will get t equals 2 pi root of L divided by g square plus v power 4 divided by r square. So what you have observed here in this question, we have considered the combined effect of two accelerations. Now let's see next question. Next question says, a cylindrical piece of cork of density of base area A and height h floats in a liquid of density rho. The cork is depressed slightly and then released, so that the cork oscillates up and down simple harmonically with a period of t equal to 2 pi h rho upon rho 1 g. So here situation is like this. There is liquid and this is cork, right? Now it is depressed through distance, say y, then it will start oscillating, right? The densities are given. The cylindrical piece of cork of density of base area A and height h floats in a liquid of density rho 1. Density of cork is rho. It's not given here, but here it is used. So let's see how we can calculate the expression for time period. So we can easily calculate. So when, let's write it, let cork is depressed through height y, right? Since it is depressed, then there will be upthrust force, so we can calculate that force. So force will be weight of liquid displaced, right? So here we need area of cross section and the height through which it is depressed, then volume into density. So we need volume into density into G. So this mass, volume into density into G. So this will become weight. Although it will be restoring force, so it will be of negative sign. Later on we will make use of that sign. First let's evaluate. So we assume that area is A and height through which it is depressed is Y. Density of liquid is to be taken as rho 1. So we write it rho 1 into G. Correct? So this is a restoring force. If you want to write negative sign, so just write here everywhere. Right? And clearly here A is constant, rho 1 is constant, G is constant. So you can say that F proportional to Y, and we can write F equal to Ky. So from here we can get K equals these values. F is minus Ky. So A rho 1 G. A times rho 1 times G. This is value of K. Right? Now let's see what is mass of cork. So mass of cork, it will be its volume into its density. So volume is area into its height. So height is, this cork has height h overall. It is depressed through y, right? So volume A h, its density. Density is rho, right? So this is mass of cork. Now all that we need is to find out the period of oscillation. So it is simple to find period of oscillation. T equal to 2 pi root m upon k. Right? Here we have found the value of m, we have the value of k also. So let's write the two. So what it becomes? T equal to 2 pi root m. What is m here? M is A, then h, then rho divided by here A rho 1 G. So A and A will cancel out and we will be left with 2 pi root of h rho divided by rho 1 G. So this is final expression. Now we are going to see next question. Next question says, one end of a U-tube containing mercury is connected to a suction pump and the other end to atmosphere. A small pressure difference is maintained between the two columns so that when the suction pump is removed, the column of mercury in the U-tube executes simple harmonic motion. So question is simple, just it needs an analysis. So let's analyze it and then we will try to find out the expression for its time period. So we draw This is YouTube, in which liquid is already filled, and the in two limbs the level of liquid will be equal. Initially, suppose it is up to here. Now, when it is depressed through, say, distance, say y, then it will raise to this height. It will raise to this height y, right? So if we see the difference between the two levels, we will find it equal to 2y, right? And when it is left, means after depression, means when you are pressing it and if you leave it, then liquid will start oscillating, and here our concern is to find its time period, right? So for that we have to consider the mass of liquid that is oscillating here, the mass of that portion. Also we have to consider that it is depressed. So let's see one by one. So area, we take area, say it is capital A, and height of the liquid, initially this was h, so height is h, and then mass of liquid, if we find, so it will be volume into density, so A H into rho, right? Now when liquid is depressed through, when liquid is depressed through y, then restoring force we can find, and restoring force will be equal to F equal to negative sign A into height, so we have to take it 2y, this is volume, into density into G, right? So F equal to minus A into 2y into rho into G. You have understood why I am writing this y to y? Because this is depressed by y, so this will raise by y, so difference between the two levels will be 2y. Here clearly we can write it as F equal to minus ky. So we can say F proportional to y. So it is simple harmonic motion. Here we have to find out what is k. So k will be equal to leave y 2a rho g, right? So value of k comes out to be 2a rho g, right? Up to here I think there is no problem. Now what next? We have to find out the expression for time period. So t equal to 2 pi root of m upon k. We have found all necessary information. We have value of k, we have mass of liquid, so just put them. So if we put it, so what do we get? 2 pi root of m. M means what? This thing, a h rho divided by k. So k is 2a rho g. So what is left? H upon 2g. So it becomes 2 pi root of h upon 2g. Here, what is h? If in terms of length, we say this is h, this is here. So if this thing is the total length, as you know, so we can write 2l here, the value of Is there something missing here? Mass of liquid. So here I think we missed it because this is height h. Here this is, instead of writing h, because one portion we have considered, so you have to multiply by 2, right? So if you multiply by 2, so here there will be change, 2 will come over here, so 2 so 2 will cancel out, and we will get 2 pi root h upon g. Correct? So that was mistake here. So we can say this h, 2h will be equal to L. This 2h is equal to L. L means this total length, and this is h, this is h. The situation like this. In this column, this is h, and here also this is h. So h, h, and this is making as L, right? So 2h equal to L. Here we have h. So h equal to L by 2. So what we do? We write final expression T equal to 2 pi root h equal to L by 2. So L by 2g. So this is final expression. So I think you have understood. But if you wish, I can just give a quick recap for this so that you can easily understand. So this is important question, and I think you can easily solve. Let's have a quick recap for this. So this is YouTube, in which up to this height there is a liquid. So here, say this height is h. So total length here, this is h also. So length is equal to 2h, right? So whenever there will be need of replacing h, in that case we will write L by 2, because generally T equal to 2 pi root L upon G. So here L is to be replaced. So L upon G, this is general expression. But here in our question we need T equal to 2 pi root M upon K. So all that we need is the value of M and value of K. So M means mass of this liquid. So mass of liquid, say M, can be easily found by taking area into height. So height is 2h into its density. Correct? So A into 2h into rho will be the mass of the liquid. And one more thing we need. What is that? That will be, suppose we depress it through distance y, in that case there will be restoring force. From where we will show two things. One, that this is simple harmonic. Second, we will find the value of K. So we can say a restoring force F will be equal to minus. Then here what we are doing, we are pressing it through distance y, then it will raise through distance y. So difference between the two levels will be 2y. So we can write A into 2y into density into G. And clearly, what do we notice? Here we notice that this is SHM, because F proportional to y, or F equal to minus ky. So we can find the value of k from here. So what will be k? K will be, leave y, then 2a rho and g. So we have got the two values, right? Now what is left? Very simple thing. So here we find the expression for time period t equal to 2 pi root m upon k. So we put the values 2 pi root m. M means this value a into 2h into rho divided by this 2a rho into g. Right. So what is left? 2 will cancel out, a will cancel out, rho will cancel out. So we will be left with 2 pi root of h upon g. But as I told you, h is equal to L by 2. So 2 pi root L by 2g. So this is final expression. I think you have understood. Thank you for watching. Team Educate.